Hi everyone, this is Karthika, Faculty of Physics, working in SNS College of Technology. So in this session, I'm going to explain about the nanomaterials. So here we can see the introduction, what are the quantum structures, synthesis of nanomaterials, and then properties of nanomaterials. So nanomaterials, we know that is nothing but the size ranging from 1 nanometer to 100 nanometers, and then nanotechnology is the science and applications of nanomaterial and is growing at ever increasing pace. So at this particle size, the properties of material can be altered dramatically. Properties such as solubility, reactivity, spectroscopy, electrical, magnetic, transport through the membranes, etc., are generally different from those of the same material with large particle size. So the applications of material of nano size have been escalated in the last 15 or so years and are currently gaining momentum. So here we can see the quantum structure. So the nanomaterial in the range of 1 to 100 nanometer, at least one dimension. So the classification based on the number of free dimensions. So first we can see the 0 dimension. All the 3 dimensions are in the nanoscale. For example, nanoparticles, colloids, quantum dots, and one dimensional nanomaterial. So here one dimension beyond the nanoscale and two other dimensions are in the nanoscale. For example, nanowires, nanorods, nanotubes, and biopolymers. So 2D nanomaterials is nothing but any two dimensions can be outside of the nanoscale and one dimension will be in the nanoscale. For example, plate like space, nanolayers, surface coating, and then thin films. Finally, we can see the 3D nano material. Here all the 3 dimension can be outside of the nanoscale, made of materials. For example, nanoparticle dispersion, nanowire, nano bundles, and then multiple nano layers. So these are the quantum structures. So this picture also shows the same thing. So for a electron in one direction, the electron confined in the one direction, that is called quantum well. There is nothing but a thin film. So the electron can easily move in two dimension, electron confined in a two direction. So this is nothing but a quantum wire. So electron easily move in a two dimension, and then we can go with the three dimension. Here this is nothing but quantum dot. So here the electrons can easily move in a 0 dimension. So each of the dimension confinement changes the continuous or movement of the electron that can be characterized in a quantum numbers. So here we can see the synthesis of nanomaterials. Here we have two processes called top down process and then bottom up process. So in a bottom up process, a small individual atoms can be combined together to make a bulk object. This is nothing but growth of a crystal, synthesis of nanoparticles by the colloidal dispersions. So here we can see the different methods called electrical arc evaporation, laser evaporation, chemical deposition method, and then magnetron sputtering, and then nanoreactor synthesis, Hall gel method, hydrochemical synthesis, and then supercritical fluid synthesis. Then we can see the top down process. In this, based on the principle here, the bulk object can be stepped down into the nanoparticles. So here we can see by the cutting, milling, and shaping and decomposition, so the nanomaterials can be prepared. So here we can see the different techniques called mechanical milling, sonochemistry, removal of component formed from the heterogen system. So these are the comes under the synthesis of nanomaterials. So here we can see the properties of nanomaterials. So the properties of nanomaterial has a unique when compared with the bulk object. So here we can see the different mechanical properties, thermal properties, melting point, electrical properties, magnetic properties, catalytic properties, and then diffusivity, and then optical property. So if we see the mechanical properties, the crystalline structure is very unique and strong. So it has a high mechanical strength. So it has a high mechanical property. So if we go with thermal properties, and this also having much more higher than the bulk materials. And then we can see the melting point. The melting point will be very less in compared with the bulk material. And electrical magnetic property, in magnetic property sometimes um, the paramagnetic material can become a ferromagnetic material by reducing their size. So likewise they have a different properties while reducing the size, which will be very useful in upcoming technologies and the applications. Here we can see the properties, mechanical properties, and the some other properties like optical properties, thermal properties, so which have a slower process, and this can be seen detailedly. And the electrical properties, electrical conductivity decreases when the size is reduced, for example polymeric fibers. And then magnetism in nanomaterial, I already told, sometimes the paramagnetic material becomes a ferromagnetic when the size is reduced. Thank you.